Okay, friends, welcome to part 2 of our video presentation on chapter 4. In this part, we will talk about two specific approaches to data modeling. Now, in the first part, we talked about ERD modeling, but ERD modeling or ERD notation is more like a language for describing data components. This language can be used as a part of more general approaches to constructing enterprise data models. Now, the first approach that we will discuss is enterprise modeling. Now, this approach has been quite popular, I would say, since 1990s approximately. But I think it's also, this approach is also losing momentum a little bit, and we'll reflect a bit later on that as to why this approach may be losing momentum or losing popularity among practitioners. But nevertheless, enterprise modeling approach is a top-down approach. It starts at the top, meaning there is an assumption or there is an approach involving somebody at the top, kind of sitting down and describing the entire enterprise data model from top to bottom. It also provides a high-level model of data, and in general, overall, it describes organization and data requirements, at a high level, independent of reports, screens, or detailed descriptions of data processing requirements. So it starts from general, and then it can be translated into specifics. Now, this diagram does a great job illustrating what enterprise modeling approach is all about. Again, it starts with this top vision of what an entire organization is. So you take your organization and you divide your organization into several functions. And functions are typically linked to specific departments. For example, there can be an organizational function related to marketing, there can be an organizational function related to accounting, to production, operations, finance, and so forth. Okay? And then each function is subdivided into broad functional processes. And then within each functional processes, you also find specific activities. And then for each activity, you list specific data entities associated with, or being used by each of the activities. For example, in this case, it's entities or data about customers, products, orders, and bills. And sometimes, it can be aggregated by looking at various activities and trying to find something that is in common. For example, one thing that is in common between those two activities is the necessity to keep track of information about customers. And this is how this general entity called customer is derived based on enterprise modeling approach. So it's like a top to bottom approach. You start from general and then you get down to specifics. Now, another approach is called view integration. It's bottom-up approach, not top-to-bottom approach, but bottom-up approach. So basically, this is how it happens. Each report, screen, form, and document produced from databases is identified. So basically, it means like you give every user whatever he or she needs for the job, for executing his or her duties. Okay, and then what's going to happen is that the data needs of individual customers or users will be extracted and then normalized. Normalized means like there are specific normalization techniques. It's an entire subfield in data modeling, and there are mathematical proofs of those normal forms. But generally speaking, it's all about aggregation. You aggregate different data requirements or different views that different users have. And then you're trying to see what is redundant. In other words, what is the overlap, what are the things that are similar, what are the entities that are similar, and what are the entities that are redundant. So based on those individual views, you create like a general model of an enterprise. So it looks something like this. You have different data needs, and here, like let's say, just like an aggregated collection of entities used by different users. And then, based on that, you can combine those things and create like a general, entities like related to parts, related to orders, related to suppliers, related to line items. So you go from specific data needs of the organization of end users to general categories or general entities, and you achieve that through normalization. So this is a bottom-up approach. Now, I told you in the beginning that, in my opinion, enterprise approach to data modeling is losing momentum. I think, in my opinion, the reason is that the enterprise approach is just not very realistic. I mean, nobody is smart enough to kind of sit down and analyze the entire organization and come up with data needs based on that analysis. Empiricism, reality is our best way to understand what kind of needs a particular enterprise have. So I think this is like this normalization as approach is more realistic. I mean, you start with what's actually needed in your enterprise, and then you try to make some kind of conclusion. So you try to aggregate those things. Starting at the top may be too problematic because, as I said, nobody's smart enough to understand data needs of specific users from that top approach. And that's why enterprise modeling, in my opinion, is losing popularity. A lot of organizations find it's not realistic. An organization is just way too complex to do this kind of analysis. Things change too fast. So let users, let field workers drive your data model, not the opposite, where you, as some kind of central master plan, are trying to dictate to individual users what their requirements are. Now, what some organizations do, they buy packaged data models. For example, an organization can buy an ERP system, and as a part of that ERP system or enterprise resource planning system, or in general, like any kind of big enterprise system, you can already have like data models coming with it. In other words, there are already databases being, that were built to support this particular enterprise system or ERP system. Now, because those databases were already supplied with the system, then organizations, in a way, they kind of purchase those data models, and they start using it. Now, of course, there is a great advantage in doing so. First of all, there's an advantage on the dimension of time. I mean, you get those models immediately, you unpack those models, and you're ready to use. Number two, those models, they're based on extensive research by software vendors, by business analysts that work for those software companies that produce those systems, that produce those data structures. So it's based on extensive research about best practices, what are the current practices, and so forth. So this is the advantage. It's quick. It's built based on best practices. You don't have to spend time building your own data models, and in a way, you get like a consulting service because they already tell you what you need right now and what you will need. Of course, there's a disadvantage when it comes to buying a prepackaged data model. Now, one obvious disadvantage that comes to your mind probably is that it's not customized. In other words, an organization may have very unique data requirements, very unique data models that are very specific to their company or their industry. And because the data models that they purchased, it's already ready-made, it means there is a limited degree to which custom needs of companies can be accommodated. Of course, modifications can be done to those prepackaged systems, but typically this requires a lot of time and money to do those kind of changes. Now, if you think about this issue about inability to customize, in addition to creating like a certain degree of inconvenience, I guess, there's also strategic implication. Now, think about it. Nowadays, a lot of industries are extremely competitive. And in order to survive and flourish in those industries, companies need to be different. There needs to be something different or unique about their products or services. Otherwise, if they're just like anybody else, they will quickly go out of business because, there is that principle in competitive industries where the winner takes it all, the best, the most innovative companies, the companies that offer the most unique, the most valuable offering, they're the ones who make most of the money. And then everybody else is just trying to tag along and survive. Now, if those prepackaged models, if a company buys prepackaged model, then by definition, at least in terms of the data models and data stores, they'll be doing exactly the same thing as many other companies who bought this prepackaged solution. So there seems to be like some kind of limiting from a very high strategic level. Those prepackaged data model, they bring some kind of cap or limitation on the degree of uniqueness of individual companies, at the minimum with respect to their data model. So that may limit their uniqueness and their ability to offer their customers something different, something unique. So because of that, some organizations may prefer to build their own data models and their own data management practices, something that would support their unique business models or unique ways of doing business. Now, some general data modeling guidelines. First of all, any kind of data model needs to start with an objective, meaning, a data model needs to accomplish a very specific goal. For example, to support customer service or to improve innovation capabilities of an organization. So there needs to be a clear objective. If there's no clear objective, then we can say that we're just cluttering our data storage with unnecessary information that may never be used. Also, one thing to think about when building data models is scope. I mean, it's obvious that scope means size of your data model. If you're trying to capture and accommodate everything, so if you're trying to store information about everything, then your data model will become unnecessary, complex, and also complex to the point where it will become unmanageable. Also, you need to take into consideration the outcome. The more uncertain the outcome, the lower the chances for success. So I think it has like overlap with the subjective criteria. Basically, what it means is that you need to understand why you are building this model for. I mean, are you building it for specific? Are you building a data model for a specific application? What is the outcome? Because if there's no specific outcome, clearly formulated outcome of a particular data model, then how will you know whether this data model is actually successful, is actually valuable, or not? So there needs to be a very specific outcome for every data model. And then another consideration that needs to be taken into account when building data models is timing. Unfortunately, sometimes building a data model for an existing organization is like trying to fix an engine of a train that is going full speed. That's extremely difficult. Another way to explain this is that you cannot ask an organization to stop taking orders from customers until you fix their data model and you make sure that everybody is compliant to that data model. Fortunately, it doesn't work that way, and that's why this enterprise approach is often viewed as unrealistic. I mean, you just cannot build your own model from scratch. You always have to start with whatever organization is doing right now in terms of the data, because every organization is like a running train, and you cannot just stop that train, or you cannot like launch your own train. You just need to go with the train that is already running. Okay, so timing is an issue. I mean, a sophisticated top-down approach requires a lot of time, and this is something that a lot of organizations simply do not have. They cannot stop their processes simply because they will lose money and go out of business if they do that. A few comments about some technologies that are used in data modeling. Now, some of the third-generation language models, or some of the modern technologies in relation to data modeling, has made the job of creating data models, storing data, and retrieving data easy. Now, one of those technologies is the so-called structured query language, or SQL. Now, this language is embedded in a lot of specific implementations of database management systems, and it's quite useful when it comes to talking to the databases, meaning asking databases the questions that you may have and getting answers for those questions. So here you see an example of SQL query. Basically, it's a code that asks the database a specific question. So in this case, the code says select order ID, customer name, order date, which are specific attributes from customer and order, meaning from two tables. And the criteria are as follows. Order date needs to be greater than this date. In other words, it needs to be newer than this. The order needs to be newer this date. And records in both tables have to be matched by customer ID. So there's this command to match records in both tables. So this is an example of SQL query. Another language or another technology that has been quite useful is the so-called XML, or extendable markup language. Now, it's different from HTML, although the idea is quite similar. Now, with HTML, you describe how you want your web page to look like through a browser. Now, XML is used to describe data. For example, if you have two applications on the web, let's say you have a website that lists and analyzes scores from baseball matches, and then you have an organization that keeps track of all baseball statistics. Now, both organizations may have a database or may have applications that do their corresponding things. In other words, an application for a website that uploads or publishes data related to baseball, and then some kind of database for that statistics company that keeps track of baseball games and player statistics, right? Now, these two applications, they need, in order for them to collaborate, in order for this database from the sports analytics company or sports statistics company, in order for that database to supply data for the website, the two applications, the two databases need to talk. And more specifically, they need to talk over the internet. Now, since those two databases or those two applications, can be developed using different approaches at different time, different languages, different technologies, they may not have, or in most instances, they don't have like a language in common, something that can, common language that they can use to exchange data. So that's where XML comes into play. XML is a way to describe the structure of your data so that the application on the other side can understand what kind of data you're sending. So that two applications can talk and share data on the web. Now, XML has been quite important over the years, but it looks like nowadays it's losing its dominant position to another similar technology. It's called JSON. Now, JSON stands for JavaScript Object Notation. It's a lightweight data interchange format. It's easy for humans to read and write, unlike XML, and it's easy for machine to parse and generate. So my impression nowadays is that a lot of the data on the web nowadays is increasingly being distributed using JSON language and not XML language. Okay, friends, so this concludes part 2 of our Chapter 4 presentation on managing data resource. Thank you for listening.